Hi, old bull guy with a pulse here from Team 1989. We are getting ready to print stuff for next season. Next season's frame is going to be based on pieces like this in different sizes. That's the core piece. And we need to make a holder that holds the motor and the gearbox, which is about 10 pounds, which looks like this. So, and it will drive a 6-inch wheel. Okay, so usually all our prototyping we do in hips because it's cheap and easy to print and relatively strong. I probably will make a video on hips one of those days, but we're out of hips and the new hips is not going to come in for a week. So I have some ESUN ABS laying around. I occasionally buy ABS when it's cheap, under $10 a kilo I mean. So I bought this for I think $7 or $8 a kilo. It was on sale. Reason is because, well, I don't think people like the color. Nobody asked likes the color. So this particular roll is called translucent blue. Was on sale on Hobbyking for about $7 or $8. So I used the opportunity to show how we're dialing filament in. We are using almost exclusively now volumetric printing. So that means marlin, which my printer supports, has as a firmware, can use volumetric printing, and we use for that reason slick 3R to do the slicing. And the first thing for volumetric printing you need to do is you need to determine what the maximum flow rate is. Hi, a week has passed. The video I shot initially did not come out right, so we're going to do it differently. I cannot use the printer at this point because the connector of the mean well power supply melted down. Looks like this. So I gotta wait. Luckily, Matter Hackers have agreed to send a new one out. They're sending it out tomorrow, so it's gonna be probably a week before it gets here. In the meantime, the print with the ABS failed because the PTFE tube popped out of the extruder, and I had to fix this. And then the hips came in, and the hips print came out nicely. The only difference is that there was a slight miscalculation, so I had to take the saw to it. You can see it's all solid through, but let's talk about the volumetric printing. Usually when you print, when you send a command like G1X and Y and E and N also stands for pull position, and the E to extrude a certain amount of filament. When you send that to the printer, under normal circumstances it will go to the XY coordinate and extrude the amount of filament, which is a length in millimeter, at a constant rate. Unfortunately, the printer in the firmware accelerates to the speed, stays at the speed, and then decelerates, or changes direction, or goes to another direction. So which means when you print out in here, you're sending too much filament, and in here you're sending too much filament to the printer, and here it's okay. So that means if you're printing a wall, and your wall is going to look like this. You have, it's exaggerated drawn, you have a widening of the wall at the beginning and at the end. So if I print a test print something like this for that reason. So if you measure with a caliper here and here, you get two different values than you get in the middle. And there's also a bridge test in it. So, which is not good if you print accurate mechanical parts. Now, when you go volumetric, the volumetric pressure for the same amount only here, this will not be sent in millimeters, this will be sent in volumetric in cubic millimeters. Okay? And the Marlin firmware, I only know for sure that Marlin works like this, makes sure that even at these positions, because when internally the ramp looks something like this, it will also ramp up the extrusion so that you get for each distance that you print the right amount of cubic millimeters, which will take this and makes those walls nice and straight and more accurate. Now this holds true for any nozzle. Now let's talk about if you print with a bigger nozzle. You first determine with any nozzle the maximum flow rate of the filament. Okay? So we want to get the max flow rate. For this we are going to extrude 50 millimeters or more, but 50 millimeters is enough. Less is not enough because you don't print out enough materials at a certain speed. So to do that at a terminal, you can type in first G91 so that you go in relative directions, and in the next line that you only have to type 1, you're going to type G1 E50 F N is the speed. If you have 1.75 millimeter filament, then 1 millimeter of filament equals about 2.4 cubic millimeter of filament that you get. R squared, which is 0.875 squared times pi, comes out to 2.4 blah 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 blah, a lot of 2.4 cubic millimeters. Now the F parameter here is determined in millimeters per minute. So 60 millimeters per minute is 1 millimeter per second, because there's 60 seconds in a minute. So which would be 60, you would be putting out 2.4 cubic millimeters. Okay, 120 would be 4.8, 180 would be 7.2, 240, etc. I think you get the picture, 9.6, etc. Okay, so you would probably work on the first one. Maybe you start at 180, G1 E50 F180, and then look at the extrusion that comes out of the extruder. And if it looks fine, if it looks like a nice line, then you're okay. Now you've added up the next line, you would type in G1 E50 F240, let's say, or any amount of that. And again you look at it. At some point, it's going to start to look something like this. Or the extruder gear is going to start to click. That means you are going past the value that the extruder can handle. So you go back to the last value, and for safety you deduct 10%. Now I talked to E3D, there is no, they do not give out a list, because these values, the maximum flow rate, is different for each nozzle temperature for the same material, and different for different materials and even brands of the same material. So you could buy some MH built PLA, and then you buy some ESUN PLA or some Hobbyking PLA, and all those PLAs have a different max flow rates that you can do. My experience so far, HIPS is the fastest, can go up to about 18 to 20 cubic millimeters per second. ABS / PLA is somewhere in the neighborhood of about 12 to 15, and nylon is under 11. Okay, and then the flexes go down even lower. So this gives you the max. Now if you have you only can do it if you have a slicer that can handle this. So now slick 3R, you would say yes to use Volumetric E, and you would add a code that's M200D and 1.75 if you have 1.75 millimeter filament, or 2.85 whatever filament size, 1.73 if you measured it and it is not right. You would send this to the printer and then set the maximum flow rate to the flow rates that you have determined. So what this does, besides, as I say, the rest probably only comes into play by filaments where the maximum flow rate is very low, or when you use a big nozzle. Okay. Now your printer has, there are a couple of different maximum speeds to consider. Okay, and you always, and you slice them, you always should use the minimum, the smallest maximum speed. The max speed for printer, which is usually the speed that the mechanics of the printer can move. Let's say on many printers it's 60 millimeters per second. That means the printer can handle moving at 60 millimeters per second without having too many artifacts ringing and stuff like this. Then there is a max speed for the filament. So for example, Tallman on that nylon recommends that you print, let's say, example, Tallman says smaller 30. So even if you have a 60 millimeter per second printer, or a printer that can print at 500 millimeters per second, I don't know of one, you cannot print Tallman at 500 millimeters per second, because at 30 millimeters, faster than 30 millimeters per second, the layers are not going to stick to each other. And then, let's say for example, we are printing any kind of material with a 0.8 nozzle, with a layer width of, let's say 1, usually it's 0.96, but it's easier to calculate, and just to make the calculations easier, and layer height of 0.5. So that means 1 times 0.5, which is layer width, times layer height, is in this case 0.5 cubic millimeters per millimeter of print that you have. Okay? So now let's assume furthermore that the volumetric rate max volumetric is 12, okay, for this 0.8 nozzle, which I'm running on my E3DV6. So if I go then 12 divided by 0.5, this is this number here, I get to 24. So the theoretically max speed that you can print on that particular hot end with a 0.8 nozzle, with a layer width of 1 millimeter and a layer height of 0.5, material that is has a maximum volumetric rate of 12 cubic millimeters per second, is with 24 millimeters per second. Now this can become quite arduous if you want to always figure this out. Now luckily, SlickSRIA, if you put the 12 millimeters per cubic millimeters per second in its max volumetric speed, it will, and you have it set to a layer width of 1 millimeter and a layer height of 0.5 millimeters, it will, even if you put in 100 millimeters per second, it will slow you down to the 24 millimeters per second to give you good output. So you don't have to worry about the speeds. Granted, with a 0.4 millimeter nozzle, where the layer width would be maybe 0.5. If you run 0.48, 1.2 is recommended. Let's make it 0.5 is here, and let's say you have a layer height of 0.2, which is 0.5 times 0.2 equals 0.1. And then if I go to the 12 divided by 0.1 would be 120. So for the filament, I could extrude, I could print at 120 millimeters a second with a 0.4 millimeter nozzle, but then I cannot exceed the 60 millimeters per second because the printer cannot handle it, or if it's nylon, I might not be able to exceed the 30 millimeters per second that the limit is on the filament. So you come down to the smallest filament. So the bottom line is the volumetric, make sure you don't get into trouble by extruding too much, and so it sets it down to you and it does those comparisons for you. Well, there's no setting right now for the maximum filament speed for the filament, except when you go into like SlickSRIA, where you set the speed for the outside layer, default speed and stuff like this, where you would put this speed in. So SlickSRIA then would, so if then let's say 30 and you have 80% for the outside layers, which is 24, SlickSRIA would slow you down to the smaller speed of the volumetric, or what your speed is what's set. Now if you have sent the command over to, and you have enabled Volumetric E, then you also get the benefits that I mentioned before. But this math here can help you on any slicer when you get to a bigger nozzle, I would say 0.6 on up, to figure out how fast can you actually set your speed and print. If you do not have SlickSRIA printer that does volumetric and you want to print at this layer height, you can use this formula, and then you would say maximum speed I can enter is 24 millimeters a second. I hope you enjoyed this video. Next time we're going to do some printing as soon as my printer is fixed again. And support Team 1989 if you can. There's some information at the bottom of the video on how to do that. And let me know what you think and what else you might be interested in. Goodbye, until the next time.